Hi, this is Nimla Rednam. In this video, we are going to start the topic surface areas and volumes from NCERT textbook class 10. This is the 12th chapter in the textbook, and we are going to begin the topic by first discussing all the formulae that we will be using in this particular chapter. We have two exercises here. The first exercise deals with surface areas. So let's first discuss what we already know, that is the surface areas of standard solid shapes. Then we can move on to the exercise in the next video. The standard solid shapes that we have studied so far are, we started with the cube, right? And then we have cuboid. And then we also are familiar with cylinder. Okay, and cone and a sphere, and here I'm going to specifically mention hemisphere because all the problems that we are dealing with have the hemisphere, right? So let us look at the surface areas of each one of these solid shapes. Let us discuss the formulae in detail, how we derived it, so that you don't have to mug it up and you can remember the formulae logically. So let's look at cube first. Okay, I'm going to draw the figure. We know that a cube has 6 faces. All the faces are squares, right? So this is my cube. Now let us say that each of these squares has a side length of A, right? Then what is my curved surface area going to be? It's actually, there's no curved surface area. This is lateral surface area. Okay, when you have cylinder, cone and sphere, we talked about the we will be talking about the curved surface area. When it comes to cube and cuboid, you will see the lateral surface area. That is, you are not considering the base and the ceiling, the top, right? Only the lateral faces. Okay, so you can see that there are 4 lateral faces, 1 2 3 4. So each one is going to be a square, so it is going to be 4a square, right? So this is your lateral surface area of the cube. When it comes to total surface area, you will be adding both the base and the top as well, and it becomes 6a square. Simple, right? Next let's look at a cuboid. So a cuboid looks like, you have rectangular faces, right? And by standard notation, we call them LBH, which is length, breadth, and height, right? So if this is my cuboid, okay, I'm taking this as the base. This is length, right? And this is breadth, okay? You can see that this will become the height of the cuboid. It simply depends on how you're placing your cuboid, and depending on the question, we are going to decide it. So this is the base and this is your top, and lateral surface area is going to be, you are not going to consider LB, which is the area of the base, and another LB which is at the top. So it is going to be 2 times of BH, right? And then this face, which is LH. This face is LH, right? So I'm going to take H common, and I'm going to have L plus B. Now suppose the cuboid is placed in a different orientation, then you will take accordingly the base as whatever fits the particular sum, and then proceed. Now total surface area, you will include both of these, so you'll get twice of LB plus BH plus LH. Now this is the cuboid, which is, after cube, if you understand cube, understanding cuboid is quite easy. Now we will move on to the curved surfaces that we have in cylinder, cone and hemisphere. So next, let's look at a cylinder. Okay, cylinder, you have a curved surface for the lateral part, and we are usually looking at circular cylinders, so the base and the top are going to be circular in shape. So this is going to be the axis, this is going to be the height of the cylinder, and from the center of the base, this is going to be the radius of the base or top, right? So when it comes to this curved surface area, we have to consider the circumference of the base, which is 2 pi r because it's a circle, and multiply it with the height here. That will give you the surface area of the lateral part, the curved surface part. So 2 pi r here is the circumference of the base, the circle, into h, the height of the cylinder. This is what is the curved surface area of the cylinder. Next, when we talk about the total surface area, you simply have to add the base and the top to it, right? The base is a circle, so we know that the area is pi r square, right? Area of a circle is pi r square. Top is also pi r square, so I have to add 2 pi r square to this. Then I am going to get the total surface area. I will take 2 pi r common and write it as h plus r. This is going to be the total surface area of the cylinder, right? Next, let's move on to cone. In a cone, again, it's not mentioned, but by default, we are going to take a right circular cone. That is when you say right, the axis is perpendicular to the base. And when you say circular, the base is circular in shape, right? So this is the right circular cone. This is the height of the cone. This is the radius of the cone, and this is the slant height. This over here, from the vertex to the base. This is the slant height, and it is denoted by L. Okay, so here when we are talking about the surface area, the curved surface area is going to be pi r L, right? And the total surface area, you simply have to add pi r square to it, which is the area of the base. This is the base circular pi r square. So when I take pi r common, I'm going to get pi r into L plus r. This is the area of the total surface area of the cone. Now let's look at hemisphere. I'm talking only about hemisphere and not sphere because all the sums in this exercise are dealing with hemispheres, right? So hemisphere, you have, okay, you will have a circular base, okay, and you have to remember, unlike cylinder and cone, where there is no relation between r and h, relation in the sense there is no correlation between the radius of the base and height of the cylinder, in a hemisphere it is not the case. If r is the radius of the base, then this is also r. You have to always keep it in mind, because in some problems, in some questions in the exercise, we are going to use this particular fact or this particular logic, that the height of this hemisphere is nothing but the radius, because this is the height supposedly, but this is we know that it is a hemisphere, so it is going to be from the center of this sphere or hemisphere, every point is going to be at a distance of r, and therefore height also is going to be r, right? So now here the curved surface area is nothing but half of the surface area of a sphere, which is half of 4 pi r square, which is 2 pi r square. Okay, and you have, when they're talking about total surface area, if we come across it, you simply have to add the base to it, which is pi r square, so it becomes 3 pi r square, right? So this is about all the formulae that you will be needing, you will be requiring for solving exercise 12.1, and everywhere we are going to be using 22 pi 7 for the as a value of pi. And once you register these formulae through these figures and try to remember them logically, you won't be confused while solving the sums. Wherever you're using the formula, you won't be confused. So that's it for now. In the next video, we will be solving the questions from 12.1. There are 9 questions in the exercise. And as for any topic from geometry, drawing figure and understanding the figure is very important. Once you can visualize whatever is described in the question, solving the sum is going to be very, very easy.